All right, so today we're going to be shifting gears a bit and really getting into this idea of kinematics.
Yeah, now.
All that stuff about speed, velocity, acceleration, like what makes things move.
The physics of motion, yeah.
Exactly. And we've got a really cool set of resources for this deep dive.
Okay.
We're looking at excerpts from this educational website. It's called Open Educational Resources/Open Source Physics at Singapore.
Wow, what a mouthful.
I know, right? But they put together this really neat JavaScript simulation to teach secondary school students about motion.
Oh, cool.
And what's really interesting about it is they use cars as examples.
Oh, neat.
I mean, who doesn't love a good car analogy?
Yeah, it's very relatable, right?
Yeah, so buckle up, because we're going to explore how this simulation can help students and you understand these fundamental laws of motion.
All right, sounds good.
So let's jump right in.
Okay.
How does this simulation actually work? What can you do with it?
Well, it lets you explore different types of motion, right?
Yeah.
So you can see what it looks like when something's at rest. You can look at constant speed, and you can even look at acceleration.
So like speeding up and slowing down.
Exactly, speeding up and slowing down.
Now, what I thought was really interesting is that it goes beyond just the visuals.
Right.
It actually encourages you to think about the math behind the motion,
Yeah.
using equations to describe how a car's position changes over time.
That's really important to developing a true understanding of it.
It's like, hey, it's not magic, it's math.
Exactly.
And speaking of math, they even provide specific equation examples like x equals 0 for an object at rest or x equals 1 times t for constant velocity.
Yeah?
Can you kind of break down what that means for someone who maybe isn't super fluent in physics equations?
Sure. So that x represents the position of the car,
Okay.
and that little t that stands for time.
Okay.
So that equation is basically telling you that for every unit of time that passes, the car's position increases by 1 unit of distance.
So if we're talking about like seconds and meters after 1 second, the car would have moved 1 meter.
Exactly 1 meter per second constant velocity.
Gotcha.
And they go on to emphasize this even more when they talk about graphs,
Okay.
because graphs are really, really key to understanding motion.
They're like the secret decoder rings of physics.
That's a great way to put it.
They're the visual representation of the math, which sometimes can be a lot easier to grasp.
Yeah, absolutely.
And they focus specifically on displacement time graphs and velocity time graphs.
Right.
And they really drive home the point that the shapes of these graphs tell you a lot about the motion.
Yeah, they do.
Yeah.
You can glean a lot of information just from the shape of the graph.
So for instance, if you see a flat line on a velocity time graph, that means the object is moving at a constant velocity.
Yep. No change in speed, nice and steady.
But what happens when we see a curved line? What's that telling us?
That means the velocity is changing.
Ah,
So that means acceleration is happening.
and the steeper the curve, the greater the acceleration or deceleration?
It's exact. Think about like if you're gently pressing down on the gas pedal versus if you slam on the gas.
Okay.
You'll see a much steeper curve if you slam on the gas.
So it's like those graphs are translating the feeling of being in the car into this visual language.
Exactly.
That's pretty cool.
It is.
Now, the website also outlines some specific learning goals for students who are using the simulation.
Okay.
And a lot of it comes back to these graphs. Like they want students to be able to plot and interpret them, to be able to tell just by looking at a graph whether an object is at rest or cruising along or speeding up.
Yeah, they really want them to be able to decode those graphs
Exactly.
and be able to translate that back into what's happening in real life.
And here's where it gets really interesting.
Okay.
They use what they call a progressive mathematical model.
Okay.
So they start with simple equations like the ones we were just talking about.
All right.
And then as you explore different types of motion, the equations get more complex.
So they're building up, right? They're scaffolding.
Yeah, it's like they're building a solid foundation and then adding layers of complexity as you go.
Which is a really great approach because it mirrors the way that we naturally build up understanding, right?
Yeah.
It's much more effective than just throwing a bunch of complicated equations at a student and expecting them to just figure it out.
It's like those video games where you start at level 1
Yeah, exactly.
and you slowly work your way up. You gain new skills and abilities as you go.
I like that analogy.
Keeps things challenging but not overwhelming.
Yeah.
So we've got this awesome simulation that uses these familiar examples, connects the visuals to the math, and then builds on that foundation in a way that makes sense. But there's one more piece to this puzzle that I found really fascinating.
I'm intrigued. What's that?
The way they've integrated technology into this.
Oh, yeah.
I mean, technology can play a really powerful role in education.
Absolutely.
So what specifically caught my eye is that they mention using platforms like Edmodo, or even WhatsApp
Oh, wow.
to keep students engaged and interested.
That's really
I
interesting.
mean, these are tools that students are already familiar with
Yeah.
using in their daily lives.
Right.
It's clever to sort of incorporate them into the learning to make it feel more relevant and accessible.
It's like meeting students where they are
Exactly.
in the digital landscape that they're already comfortable with.
And I wonder if that also helps to foster like a sense of community and collaboration among the students.
Oh, it could. It absolutely could.
Because you're using these platforms that encourage communication and interaction.
Right. You're creating opportunities for that peer-to-peer learning.
Yeah,
You
which
know,
can be really valuable.
definitely.
So what stands out to you about this approach to teaching kinematics?
Well, I'm really drawn to the pedagogical intentionality behind it.
Yeah.
They've clearly thought really carefully about how to present these concepts in a way that's engaging, accessible, and effective.
They've taken something that could feel really intimidating, like physics equations and graphs,
Mm-hmm.
and made it feel approachable and even, dare I say, fun. And they've done it without dumbing things down.
Absolutely. They've struck this really great balance between accessibility and intellectual rigor.
Yeah, it's a tough balance to achieve.
It is, but they've done it beautifully.
Okay, so we've taken a close look at kind of like the how of this simulation and its learning goals.
Right.
But let's kind of shift gears a bit here and talk about the why.
Okay.
Why should anyone care about these graphs and equations and the laws of motion,
Mm-hmm.
especially if they're not planning on becoming a physicist?
Right. A great question. Well, that's the question, isn't it? Like, why bother with this stuff?
Yeah, you telling me there's more to it than meets the eye.
Absolutely. It's easy to think of it as just another subject in school, right?
Yeah.
Something that's only relevant to scientists and engineers.
Right.
But that couldn't be further from the truth.
Okay. I'm intrigued.
Think about it this way. Every time you drive a car, you throw a ball.
Yeah.
You even just walk down the street.
Yeah.
You're interacting with the laws of motion.
Okay.
It's happening all around us all the time.
So when I like slam on the brakes to avoid hitting a squirrel on the road, that's kinematics in action.
Exactly. Understanding acceleration helps you understand why it takes a certain distance for your car to come to a complete stop.
Right.
It's crucial for safe driving.
Oh, wow.
And it all comes back to those equations and graphs we were talking about.
Yeah. Suddenly it's feeling a lot more relevant.
Right. Or consider athletes.
Okay.
A basketball player calculated the perfect arc to sink a three-pointer.
Right.
They're intuitively using principles of projectile motion.
So they're like doing physics in their heads without even realizing it.
In a way, yes, they've developed a feel for how objects move through practice and experience,
Right.
but understanding the underlying physics,
Mm-hmm.
could give them an even deeper understanding of their actions and help them to really optimize their performance.
It's like having a secret weapon.
Exactly.
A deeper level of understanding of the forces at play.
And beyond those everyday examples, kinematics plays a vital role in countless fields: engineering, architecture, robotics, animation. The list goes on and on.
So it's not just about like being a better athlete. It's actually like useful for a lot of different careers.
It's not even just careers. It's about having a framework for understanding the world around us.
Right.
Kinematics gives us the tools to analyze and predict motion,
Uh-huh.
which has implications for almost every aspect of our life.
This is really making me realize just how interconnected different fields of knowledge really are.
Absolutely.
You might think physics is this isolated subject,
Right.
but it's clearly not.
It's all connected.
Okay, so we've established that kinematics is fascinating and practical,
Yes.
but let's bring it back to this simulation for a moment.
Okay.
What are some of the potential benefits of using this kind of interactive tool for learning?
Well, first of all, it's more engaging than just reading a textbook, right?
Yeah.
But beyond just being more fun, it allows learners to actively experiment and explore different scenarios.
All right.
They can tweak parameters, they can observe the outcomes, and really get a feel for how things work.
So it's like a hands-on physics lab, but
Exactly.
without the risk of explosions.
Exactly. I love that analogy.
And this hands-on approach can lead to like a deeper understanding and a better retention of the knowledge.
Absolutely. When you're actively engaged with the concept, it's more likely to stick.
Yeah, it makes sense. It's like the difference between reading about how to ride a bike and actually getting on one and trying it yourself.
Exactly. And another fantastic benefit is that it allows learners to visualize these abstract concepts
Right.
that might be really difficult to grasp otherwise.
Yeah, I could see that being really helpful.
Seeing those graphs and watching the car move in real time,
Right.
it helps make those equations and principles a lot less intimidating.
It's like they're bringing the equations to life.
Exactly. And another thing I like is that it provides a safe space for experimentation and making mistakes.
Oh, that's true.
In a real-world physics lab, mistakes can sometimes have messy consequences.
We've all been there.
But in a simulation, learners can try different approaches. They can see what happens. They can learn from their mistakes without any real-world repercussions.
It takes the pressure off.
Exactly. And I think it encourages more creative problem solving, too.
Oh, yeah, definitely.
When learners feel safe to experiment, they're more likely to think outside the box,
Yeah.
to try unconventional approaches without that fear of failure holding them back.
So we've covered a lot of ground here.
We've explored, the features of this innovative kinematics simulation.
Right.
We've delved into the importance of understanding motion in everyday life and in all these different fields.
Mm-hmm.
And we've even discussed the benefits of using interactive learning tools.
Yeah, this has been a fun deep dive.
I've really enjoyed this conversation.
I agree. It's always a pleasure to explore the world of physics. Absolutely.
And uncover these hidden connections between seemingly abstract concepts and the world around us.
It's amazing how it's all connected.
It's amazing to me how something like kinematics can seem so theoretical on the surface.
Yeah.
But it's actually so deeply connected to our everyday experiences. It's like we've been speaking physics all along without even realizing it.
It's true. We take these laws of physics for granted because they're so seamlessly woven into our reality.
Yeah.
But when you start to understand the principles at play, it's like seeing the world with new eyes.
I feel like this deep dive has definitely given me a new perspective on things.
Okay.
I'm already catching myself noticing the motion of objects around me.
Yeah.
With this heightened awareness.
That's the beauty of learning. It opens up these new ways of seeing and experiencing the world.
So for our listener who's hopefully just as excited about kinematics as we are now,
Yeah.
what would you say is the most important thing to take away from this deep dive? I'd say the biggest takeaway is that physics isn't just, a bunch of formulas and theories.
Right.
It's a way of understanding the fundamental principles that govern the universe.
Mm-hmm.
And those principles are at play all around us all the time,
Okay.
whether we're driving a car, watching a basketball game, or just walking down the street.
It's about connecting those seemingly complex concepts to the things we experience every day.
Exactly.
So speaking of connections,
Yeah?
what are some other real-world examples that our listener might be able to connect to these principles of kinematics?
Ooh, that's a great question.
Something they could observe or even experiment with on their own?
I would encourage our listener to just look around
Okay.
with a curious mind.
Mm-hmm.
Observe the motion of objects,
Yeah.
like the arc of a ball being thrown,
Mm-hmm.
the way a car accelerates stop the swing of a pendulum.
Okay.
Think about the forces that are at play
Right.
and how those forces influence the motion.
So it's like we're giving our listener a challenge to become everyday physicists, observing and analyzing the world around them.
And who knows, maybe those observations will spark a lifelong passion for physics.
Or maybe they'll just, lead to a deeper appreciation for the world around us.
Either way, it's a win.
Well, I think we've given our listener a lot to think about today.
I hope so.
And hopefully sparked their curiosity.
Yeah.
And given them a deeper appreciation for the beauty and relevance of kinematics.
Absolutely.
We've only scratched the surface here.
But it's a good start.
There's a whole universe of fascinating physics out there,
So much to explore.
waiting to be discovered.
Keep that curiosity burning.
And never stop exploring.